welcome back. So I'm just going to go over this one. Determine the area of the shaded region. Round your answer to the first decimal place or one decimal place, right? So our shaded region is just the blue part. So in order to find out what the area of the shaded region is, it's easy for us to say the entire area is going to equal the area of the circle minus the area of the triangle because the triangle isn't the shaded part. Right? So let's try and find this separately. So I'm going to make it so that the blue is the area of the circle, and then I'll make the orange the area of the triangle, right? So we'll make the orange the area of the triangle. There's a few things that we need to do before we find the area of the triangle, so let's just go ahead and find the area of the circle first. We know the area of a circle is equal to pi r squared. We know r is equal to diameter divided by 2, which is going to give us 16, right? Because that's the length from here to here. 16 divided by 2. Okay, so I'm going to say, all right, pi times 16 divided by 2 is just 8 squared. So it's going to be 8 squared is going to give me 64 pi. And I know 64 pi is just 201. And I'm not even going to bother trying to multiply by pi. Don't try to do this in your head. Just go and put it into your calculator. So area of a circle. So the area of the circle is about 201 centimeters squared. Now, like I said, we need to do a little bit more work to find the area of the triangle, but that's okay. We know that the formula, when I look at my formula sheet here, the formula for a triangle is area is equal to base times height divided by 2. So I know my base is here, and my height is like that. So my height is going from the center all the way to the end. When you have a circle and you go from center all the way to the end, we call that radius. That's why radius times 2 is equal to diameter, right? So we know what the radius is because we already found it. We had to find it before. So we know this is 8 centimeters. We know our base is going to be 16 centimeters of that triangle. So let's just go in and put in our stuff. We're going to say, all right, base is equal to 16 centimeters. Our height is equal to 8 centimeters, right? I'm going to take that and divide it by 2. So let's just do that. 16 times 8 is going to give me, 16 times 8 is going to give me 128. Divide that by 2. I'm going to keep writing area triangle because that's good form. 128 divided by 2 is 64. That means that the area of the triangle inside is equal to 64 centimeters cubed, right? And I know from my formula before, the total area is just equal to my area of my circle minus area of my triangle. So I'm just going to start putting in what I know. I know 64 centimeters squared, right? And I know my area of my circle is 201.1 centimeters squared. And that's going to give me my total area. So let's just put that in. 201.1 minus 64 is going to give me a total area of 137.1 centimeters squared. So my total area of my shaded area is going to be 137.1 centimeters squared. Okay? So if you're starting to get this hang of this, awesome. Again, like thinking, and we're thinking of those thinking and inquiry skills, is that's what we're trying to get at, okay? Alrighty. So now we know that we have this example 4. It says to determine the area of a regular pentagon with the side lengths 5.8 centimeters and the distance from the center to the middle, or from the center to the middle of one of the sides is 4 centimeters. So let's just go draw that in. So I know that each side is going to be 5.8. This entire side is 5.8. This entire side is 5.8. And then I know from here to the middle of here is going to be 4 centimeters, right? How you're going to do this is you're actually going to go in and draw a triangle. Okay? Now you have this right triangle. you can figure out, you have this triangle right here too, right? You have 1, 2, all the same length, 2. So you have, I'm just going to put that in, 1, 2, 3, sorry, I'm running out of colors here, 3, 4, 5 triangles that make up this one pentagon. So if you find the area of one of the triangles, just one triangle, now you can find the area of the entire pentagon, because you just take the area of that one triangle, and since they're all the same, you multiply it by 5. So I know that the area of the pentagon is equal to 5 times the area of all the mini triangles, right? Now what I need to do is I just need to go find the area of that mini triangle. And how do I find the area of a triangle? I already know that. I know it's base times height divided by 2. I know my base is 5.8. I know my height is 4 divided by 2. So I'm going to say, all right, 5.8 times 4 is 23.2 divided by 2, right? So my area of the triangle is 11.6 centimeters squared. So since that's the area of one of my triangles, if I want to find the area of all of them, area of the pentagon is equal to 5 times area of one little triangle. So let's do 5 times 11.6 centimeters squared equals 58 centimeters squared. And that's how I would find that. So there's also another thing that if you go onto YouTube and you look for this, there's a formula for it. It's called area equals perimeter times apothem divided by 2. The apothem in the situation would just be that distance from the center to the middle of one of the sides of the triangle, so this height of the triangle. You could use that, but you'd still need to find, it's the same way. You're basically doing the same thing. You're basically doing 5.8 times 4, right, divided by 2, and then you would multiply that by 5. So you're essentially doing the same thing. It's just, if you want to use the formula, you can. I personally don't recommend it because I think this is a better way to visually see it. Okay? All right. So moving on, nothing is anything without word problems in the mix. So let's do that. Okay? So this is like a actual application of this stuff. So if we're thinking, so far we've been doing some thinking and inquiry questions, right? And we've been doing some, I'm just going to make sure this is recording. Oh, perfect. We've been doing some thinking and inquiry questions. We've been doing some knowledge questions. So now let's move on and actually apply what we're learning into the real world, right? So this says Jane is going to build a vegetable garden on his farm. The garden is shown in the diagram below. Jane wants to figure out how much it will cost to enclose a garden with a wooden border. He plans on using the boards shown below, so these over here, right? And he's going to build it 2 boards high. So each board that goes down on the ground, he's just going to put one on top of it, okay? So each board is about 2.4 meters, right? What we're trying to figure out is determine the perimeter of the garden. So this is a great way. Let's go determine the perimeter of this garden. First things first, I know that I have the slide length over here. That's 5. So I'm going to say, all right, perimeter is equal to 5. Let's just put the ones that we know in. We know this is 2 meters, 2.5 meters. Right? We know this is 1 meter over here. We don't know what this is, so we're going to leave this as the one that we got to come back to. Question mark. Right? We know this is 2 meters over here. So let's put in the 2 meters. We know that this is 2 meters over here. Let's put that in. We know this is 1.3. And we don't know what this one is. Plus another question mark. Our first question mark is super easy to solve. If this is 2.5 going down this way, and this is the same length. We know that's 2.5. So let's just go put that in. This is 2.5. Right? So let's just go sub it in over here. 2.5. That one was easy. This one over here is a little bit harder to solve. Right? So how can we solve this? We know that this entire length over here is 2.5. Right? We know that this portion of it is 1 meter. So if I want to find out from here to here, I'm just going to take 2.5 minus 1, which will give me about 1.5. Right? So I'm just going to go in and put that in. That's how I would find that length. And now I'm going to do the hardest part, is add everything together and hope I don't lose track. So I'm going to do 5 plus 2.5 plus 1 plus 1.5 plus 2 plus 2 plus 1.3 plus 2.5. And that will give me about 17.8. So now my perimeter is equal to 17.8 meters. Right? Really important. Make sure you put in your unit. 17.8 meters. So it says, how many boards are needed to go around the garden? Don't forget that the board needs to be 2 boards high. So let's do this step by step. I know that I need 17.8 meters worth of boarding, right? So I'm just going to say this. Number of boards is going to be my perimeter, right? So I have my perimeter divided by however much each board is. I know each board is worth 2.4 meters divided by 2.4 meters. So I know my perimeter is 17.8 divided by 2.4. So I'm going to say number of boards for 1 round. So just on the ground, just for 1 round, I need that many. So I'm going to do 17.8 divided by 2.4. And that's going to give me 7.4. So when I lay down my boards, right, at this point I need 7.4 boards when I lay it down the first time. Then I want to add a second border, which means I need to add 7.5 more meters, or 7.4 more boards. So I'm going to say, okay, 7.4 times 2 equals, and this is where that thinking comes in, right? Equals 14.8 boards, right? When we go to the store, we can only buy the boards. They're not going to give us that 14.8, so we're going to say we need about 15 boards. Cool? So what Jane says is like, you know what, just to be safe, I know I'm going to mess this up somehow, let's purchase 10% more than what I need. Just in case when I'm cutting it, I make a mistake, whatever. So we know it's 15 boards that he needs to make, right? He wants 10% more than that. So let's find out what 10% of 15 is. So 15 boards times 10% is just going to be 0.10 equals 15 times 0.10 equals 1.5, right? So he needs to make the 15 boards he's going to buy plus 1.5 more, which is just going to be 16.5. But no one's going to give him 0.5 of a board, so we're going to say roughly 17 boards. And that squiggly line just means roughly. So he's going to go ahead and buy 17 boards. Okay? Now, we know that each board is going to cost him $363 plus tax. Let's find out how much it's going to cost him in total. So we know he's going to buy 17 boards, right? And each one's going to cost him $363. So let's just find the subtotal. That's going to be our subtotal, which is before tax. Right, so let's find that. 17 times 3.36 or 3.63 is going to be $61.71 equals our subtotal. Right, so if you ever look at your receipt, it's going to say subtotal. Now, our subtotal times 1.13, which is how much tax cost, is going to give us after-tax price. right? So let's take our 61.71, and you can do this one of two ways. So I just skipped a step and I did the 1.13. You could have done 0.13 and then added it to your subtotal. Either way works. Is equal to our after-tax price. So it's $69.73 is how much he's going to pay after tax for the wood. So if he's going, he should probably go with around $70. Okay. Moving on. Just moving on. My battery's going to run out soon, so thankfully this is our last example. Again, one of those, okay, now I got to think about this examples, right? So Peter Pan Daycare wants to paint the walls of its kindergarten room. There's two walls that are 3 by 6. Plain, simple walls. These two walls are going to be easy to find, right? These other walls are a little bit more complicated. The other two walls are 3 by 5, but they have two windows, one circular, one trapezoidal, right? So they're below. The staff is trying to determine how much paint they will need to buy and how much it will cost. The diagram on the wall with the windows are shown below. So before we do anything, let's break this down. We know that there's two walls that are 3 by 6, so let's just figure out how much the paint on those walls is going to cost first. So let's go down. It says determine the total area. So paint on walls 1 plus 2 is going to equal just they're 3 by 6, right? So wall 1 is going to be 3 times 6, which is going to be 18 meters squared. Wall 2, same thing, is going to be 3 times 6, which is going to be 18 meters squared. Right off the bat, I'm done. I don't need to worry about those two walls, right? I have 18 meters squared plus 18 meters squared, right? So those two walls together are just going to be 18 plus 18, which gives me 36. Okay? Wall 3 and wall 4 are a little bit more complicated, but they're both the same. So if we find what wall 3 is, we'll automatically know what wall 4 is. So let's try to figure out what wall 3 is. So if we go up here, we go up here, we know that the entire thing, if there was no cut-ups, would be 5 times 3. So let's say the area shaded is equal to the area of the total box, or of the window, or of the square, whatever. Let's say rectangle, is area of the rectangle minus these cutouts, right? You want to get rid of the cutouts because the windows don't need to be painted. So the area of the circle, and let's make the area of the circle orange, right? So let's make the area of the circle orange. And then the area of the trapezoid. We'll make red. Area of the trapezoid. So first things first, let's just go in here and try to find out the area of the circle. We already know how to find area of a circle. We know area of a circle is equal to pi r squared. We know what d is. We know what the diameter is. We just want to find out what half the diameter is. So that would be 0.5. So r is equal to 0.5. Okay, so we have pi times 0.5. And I found that from taking the diameter and dividing it by 2 squared. Equals 0.25, because 5 squared is 0.25 pi, and I'm just going to put that in to my calculator, and that's going to give me 0.785. I'm going to leave it at 3 decimal places because I like to work with at least 3 until I have to do my final answer. Right? If you want to round that up to 0.8, that's fine. I just like to work with 0.3 until I like to work with as many decimals as I can until I have my final answer. Now, I'm going to go find the area of this trapezoid. If you go in and you look at your formula sheet, it tells us what the area of a trapezoid is. So I'm just going to label this trapezoid with the relevant letters. So this is D, this is B, this is H, and this is C. Okay, and I just took this straight from your formula sheet, which you will have access to on a test or a quiz. So area is equal to, and I'm just taking this from here, A plus B H divided by 2. So let's just put in our numbers. We have A, which is 0.7, plus B, which is 1.4, times H, which is 1, divided by 2. So I'm going to do 0.7 plus 1.4, which gives me 2.1. I'm just going to carry this up over here. 2.1. Times 1 is just 2.1 divided by 2. So my area is equal to 1.05 meters squared. So now I have my area of my trapezoid, I have my area of my circle, and I have my area of my rectangle that I need to find. My area of my rectangle, if I go back and look at my sheet, it's just length times width, which is 5 times 3, which is 15 meters squared. So now I'm just going to put in what I have. So my area shaded is going to be 15 meters squared minus 0.785 minus 1.05, right? So I'm just going to put that in. Minus 0.785 minus 1.05, and I'm left with 13.165, which I'm just going to round up to saying is 13.2 meters squared. So my area of the third wall is going to be 13.2 meters squared. And I know that wall 4 has the same setup, so I know that they're the same. 13.2 meters squared, right? So the total area of all 4 walls is equal to wall 1 plus wall 2 plus wall 3 plus wall 4. So that's going to equal 18 plus 18 plus 13.2 plus 13.2. So I'm just going to do that. 18 plus 18 plus 13.2 plus 13.2 is going to give me 62.4 meters squared is area to be painted. Okay, so 1 can of paint can only cover 35 meters squared. How many cans of paint should they purchase? So to find out the number of paint cans needed, right? We know that 1 can only cover 35. So let's take area needed divided by area covered by 1 paint can. Right, so let's take, we need to cover 62.4 meters squared. We have 35 meters squared that can be covered. So let's just divide those two. So I need 1.782 meters, 2 paint cans, which means that I need 2 paint cans because they're not going to give me that much. 2 paint cans to do one coat. Therefore, 4 paint cans, right? Because if we're doing 2 coats, we need double the amount of paint. 4 paint cans to do 2 coats. And this is like stuff we do on our own. Like we think about it. We know how to do this. If you were to go out and buy paint, you would say, all right, how much paint does my room need? How much is in each can? you would take how much paint your room needed, divide it by how much is in each can, figure out how many to buy, and then if you were going to do 2 or 3 coats, you're going to find out how much you need, right? So if you need 4 paint cans, right, each paint can costs $52, and that's a pretty reasonable price for paint, right? We're going to say, all right, so total cost before tax, right, before tax, equals number of cans, so how much you're buying, times price. So let's find it. So we know the number of cans is 4 times the $52.95 that it's going to cost before tax, which is going to give me about 211.80. Wait, is that right? 4 times 52.95, 211.80, right, dollars. And then I want to find out, all right, how much is it going to cost after tax? So if I want to find out total tax, and then this is the 2-step way if you want to do it. Total tax is going to be 211.80. We paid 13% tax in Ontario, so you'd multiply it by 0.13. So you'd have 27.53 that you would pay in tax. So total cost would be equal to 211.80 plus 27.53, which would give you about 239.33 cents. So that's how much you would pay in total for your can. Or you could do it this way. You could have done 211.8 times 1.13, right, equals 239.39. Either one would have gotten you the same answer. Whichever way you prefer to do it is up to you. All right, and that is the end of this lesson.